Hello, friend. Let's begin by working in the terminal. Today we want to talk about 2D arrays. So a 2D array is much like a 1D array, but instead of just having one row, we have multiple rows. This above would be a 4 by 5 2D array. A 2D array is also known as a matrix. It's a 4 by 5 array because it goes down 4 and across 5. We begin with the top left corner in computer science, and we begin with the y value first. So in this case, y equals 4 and x equals 5. There are 4 rows and 5 columns in this 2D array. And altering the array is just as simple as altering a regular array. Let's say that's called array. That's the name of this matrix we have above. The first bracket corresponds to the y-axis, so let's put 0, and the second one corresponds to the x-axis. So 0, 0 will update the top left corner. If we were to update that to a dollar sign, it would look like this. Instead, we update 3, 0. That's going to go down 1, 2, 3, and across 0, updating the bottom left corner. Instead, we change the second bracket. It's going to go down 3, 1, 2, 3, and across 2, 1, 2, updating this coordinate here. Play with 2D arrays. Now, making one is a little tricky in Python. What we do is we begin with an outer array. What we're seeking to do is create a list of lists, right? A list where every element is a list, and that will represent the 2D array. We're going to loop through the number of rows. Let's say there are 10 rows. Then we create a row, which itself is another list. Then for the row, let's loop through the number of columns. Let's say there are 5 columns. We'll append a certain element to start with, so let's say it's a matrix full of 0 elements, or a matrix full of the character 0. Then we're going to append the row to the list. So we're going to get many different rows, up to 10 of them. If we were to print graphic, let's see what comes up. Nice. So we have a list. The outer list, which is represented by these 2 brackets, is full of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. Each of those elements is a list. The first element of our graphic list is a list itself, a list with 5 zeros, because there are 5 columns. The second element is another list full of 5 zeros. The third element is another list full of 5 zeros, and so on and so on. So this is a 10 by 5 matrix. Now, that's a little tricky. There's an easier way to do it in Python if we import a library. The library is called NumPy. This lets us create matrices more easily. Let's call it NP so we don't have to keep typing NumPy throughout our program. And then let's make it so that the user can input the size of the matrix. For now, let's make it so that there are the same number of rows and columns. Then, to use NumPy, we define a list, which will be our matrix, and use np.full. Full will fill it with a certain symbol to start out with. So to fill it with zeros, we give it an x and y size, that is rows and columns, this being rows, this being columns, but for now we just want to keep it size and size, the same number of rows and columns. If we print this now, let's give it a 5 by 5 matrix, or a 4 by 4 matrix. Nice, it does the exact same thing as above. We have a list full of 4 lists. Each of those lists is full of the element 0. Back into our code. Instead of 0, let's fill it with a space. Now, to loop through our 2D matrix, we have to do the following. We have to do an outer loop. Let's loop through the rows. Rows here is the same as size on line 6. Then, for every row, we loop through the elements of that row. So we loop through the columns. What this is going to do is loop through every single element one by one. It'll loop like this. Let's say we have a 4 or a 3 by 4 matrix. It begins with the top left corner, then goes to the right, goes to the right, goes to the right, then goes down a row and resets 0. Now we go to the right, to the right, to the right. It resets, goes to 0, goes down a row, and goes to the right, to the right, to the right. So in that way, it explores everything from the top left corner to the bottom right corner in a similar way you would writing in the English language, beginning from the top, finishing a row, then going down. For every element, let's do the following. Let's update the element. Let's say that the matrix at the y and x coordinate becomes a different symbol. Make it a dollar sign. Then let's use the random library. Let's use R. If let's make R equal to randint 0, 1 or 0, 2. If R is 0, let's update the matrix for a different symbol. If R is 1, let's update the matrix once more. Okay, so we should get a random matrix. The matrix will either have a dollar sign, pound symbol, or an up caret. Do a 10 by 10 matrix. Nice. So we have a 2D array which is full of so many different symbols. But I'm not really a fan of these square brackets and these quote symbols, which are default with Python's print function. So let's make our own print function. Call our print function print array, or whatever we want. Then above the call to the function, let's define the function. Let's have it so that it accepts any kind of list and renames it to ARR. Now within the function, whatever is sent over, that being graphic or some other matrix, we'll do the following to ARR. We're going to loop through the matrix in the same way that we did above. And for every element, we're just going to print it, one character at a time. And make sure there's no new line. Once we've finished the for loop, remember the inner for loop, this inner for loop that loops through X represents the columns. Once we've finished all of the columns on a single row, we'll just print a new line. Otherwise, everything will appear on the same exact line, and we don't want that. Here we go. Now we have our own print array function that doesn't have the squares or the quotes. And we can see it's a randomized 2D matrix. If we run it again, let's give it a different size. It'll make it bigger, but it's still random. Okay, let's make a new file. Let's switch.py. And let's begin it like we did our last one. But of course, we'll have another few libraries. We want to use the time library and the OS library. Then instead of defining one 2D matrix, let's define two of them. And begin them with just a space as the character, a blank space. Then I've defined a second 2D array just called 2 for now. Let's create a print function so that we can use our own print instead of the Python's default print. Notice that the local variable is called ARR. We don't call it 1 or 2 because we want to be able to send either matrix over, and then this function will work with either one. Let's add some color to our terminal using some ANSI art, ANSI color. To add color, we can use the following command, /033. Then the following represents what color we want. I think this makes it bold, and I'm not sure what 32 and 36 look like, but we'll figure out that pretty soon if we run it. Then we're going to concatenate that with the following string. Whatever is in ARR at the YX coordinate, finally end equals 0, so that it doesn't print a new line at the end. If it finishes printing out a whole row, we'll just do print parentheses, which will do a new line. So similar to the last example. Then let's do the following. Enter a infinite infinite while loop, and we want to print array 1 as well as print array 2. Now they're not really filled with anything except spaces, but we can change that pretty soon. Before printing them, let's have it so that our screen is cleared. Clear our screen, do the following command using the OS library, os.system, and then clear. Clear is what you do if you're on a Unix-based system or Mac, CLS if you're on Windows. I'm on the server, which is a Unix-based operating system, so I use clear. This will clear the terminal. Then we'll delay a little. Then we'll print the first array. Then we'll delay 1 second. We'll clear the screen once more. Then we'll print the second array. Nice. So because we're using a function, look how nice our while loop looks like. Everything is indented the same, and someone can look at this and know what is exactly going on without having to look into the functions itself. So if we run this, it'll just switch between 1 and 2. So if 2 is dollar signs and 1 is the @ symbol, what does it look like? Like our ANSI art was cyan. That's pretty cool. Notice that it clears the terminal each time, so they're not overlaying each other. Okay. So before we even print them, let's update these two arrays using some formulas. Let's loop through every element. If the x and y coordinates of the element are greater than a particular value, let's update them. What line 14 is doing is it's saying, well, if x, that is the x-axis, the x-coordinate in our loop, is greater than size over 2, then we want to do the following. We want to update the one array, or one matrix, simply be a tilde. What these two lines are going to do is only update the right half of our matrix. So x has to be greater than half the size of the matrix. And of course, that means the right half will be updated. Then let's update the other matrix using a different formula. If y is less than or equal to size over 2, that is, if we're in the first or the upper half of the matrix, then let's update the second matrix to be a different symbol. Make it the exclamation point. This way we can loop through every element and use these formulas to change the symbols in them. Pretty cool. So for one of the matrices, we see the left half is full of the at sign and the right half is full of the tilde. For the other matrix, the upper half is full of exclamation points and the bottom half is full of dollar signs. Looks like there's some problem with our screen clearing. Maybe our sleep isn't long enough. If you don't delay long enough, then the system won't clear the screen before the array is printed. So let's make these two and see what happens. Okay, that's a lot better. Now they're not overlaying each other and printing too much in one frame. We want to make a program that prints an arrow on the screen. So this will be some computer-generated art. Now, we're not going to define a matrix this time because we're not going to need to save information, but the logic is largely the same. We're going to loop through the number of rows, and every row we're going to print something different based on a particular formula. Let's make sure that the width of our picture is 24 and the height is 20. We use W for width and H for height, but that's arbitrary. Then we'll use Y to loop through the rows. So we could say for row in range, but I'll say for Y in range. It'll go from 0 to just before H being the height. So Y goes from 0 to 19, that being 20 total rows. Let's define some stars. The number of stars represents the number, how many symbols are used to fill in the arrow. So the number of stars should increase if the point of the arrow is at the top of the portrait. So let's make it so the number of stars doubles each time. And let's add +1. Otherwise, the first row won't have any stars. So it goes 1 star, 3 stars, 5 stars, 7 stars, and so on. Then let's do an inner for loop where we loop through all of the columns within each row. We'll go from 0 to W. And if x is less than or equal to the number of stars, we'll print the following. We'll print a star. Otherwise, we'll print a period. When we're done looping through the number of columns and we're done with a single row, we'll print a new line before we go to the next row. Oops. There we go. We see every row has an additional star on it, but we kind of messed up. And also, we want a tail, don't we? Otherwise, it's just a pointed rectangle, or pointed triangle is the first half, and the rest is just a rectangle. Let's go back into our code. Let's do the following. If y is greater than height divided by 2, so for on the second half of the portrait, the lower half, the number of stars is just automatically 8, so it doesn't change. Let's also define a starting point for the number of stars, for the stars. Otherwise, the stars always start at the left-hand side of the portrait. We want the stars to start in the middle and then slowly open up, like the point of an arrow. And the start point would just be width minus the number of stars over 2. So if width is 24, and we currently have 3 stars, 24 minus 3 is 21, divided by 2, and then rounding down is what, 10? So the first star will appear after 10 periods. You'll see 1, 2, 3, 9 periods, then the stars will begin. Since there's only 1 star on the first row, it'll just do the remainder with periods. On the next one, it'll be 24 minus, right, then it'll be 24 minus 3. You'll get 3 stars, and the rest will be periods. Then you'll get 8 periods, 5 stars, and then a bunch of periods. So this start index represents where to start printing the stars. The end index is simply the start index, plus, of course, the number of stars. Then, let's add to line 14 on our condition of when to print the stars. Start index needs to be less than or equal to x, which is less than or equal to the end index. Hey, minutes. There we go. We see 1 star on the top, then 3, then 5, but it's always centered in the middle of the row. After we've gone through the first half of the portrait, the last half always has 8 stars. So that's how we can use computer science to generate some art.